There are several advantages to wiring a hot tub for 240 volts as opposed to 120 volts. Firstly, the water heats up significantly faster with 240 volts. Secondly, while heating up initially may take more electricity, maintaining the temperature at 240 volts may consume less electricity than at 120 volts. This is because 240 volt circuits often operate at higher efficiency because of low current flow. Thirdly, 240 volts can provide more power to the hot tub, allowing for more powerful jets and other features. Regarding energy consumption, once the hot tub reaches its desired temperature, 240 volts can consume less electricity to maintain that temperature compared to 120 volts. This is because of the lower current flow and often higher efficiency of 240 volt circuits. A full-fledged disconnect is typically required for both 120 volt and 240 volt hot tub installations. This provides a convenient and safe way to isolate the hot tub from the power source for maintenance or in the event of an emergency. For 120 volt installations, a heavy-duty ground fault circuit interrupter protected extension cord may be acceptable as long as it meets the electrical requirements specified in the hot tub's manual. However, it's generally not recommended to use an extension cord for permanent installation. The cost of installing a 240 volt circuit can be significantly higher than installing a 120 volt circuit. This is because of the need for larger wire, a dedicated circuit, and potentially trenching or other underground work. However, the long-term cost savings on electricity may offset the initial investment in a 240 volt circuit. If faster heating times, lower operating costs, and increased power are prioritized, it may be worth investing in a 240 volt installation. However, if budget is a primary concern and sacrificing some performance and convenience is acceptable, a 120 volt installation with a heavy-duty extension cord may be sufficient, as long as it meets the standards. Consider consulting a qualified electrician to determine the best option for specific needs and local electrical codes. When wiring a hot tub, either at 120 volts or 240 volts, it's crucial to adhere to the National Electrical Code, or NEC, and any local electrical codes. These codes are in place to ensure safety and prevent electrical hazards. Here are some key considerations. Firstly, a dedicated circuit is typically required for a hot tub. This means the hot tub should have its own circuit breaker in the electrical panel and should not share the circuit with any other appliances or devices. Secondly, ground fault circuit interrupter, or GFCI, protection is mandatory for hot tub circuits. A GFCI is designed to detect ground faults, which can occur when electricity flows through an unintended path, such as through water or a person. When a ground fault is detected, the GFCI will quickly trip the circuit, cutting off power and preventing electrical shock. Thirdly, a disconnect switch should be installed within sight of the hot tub and readily accessible. This allows for easy shut-off of power to the hot tub for maintenance or in case of an emergency. The disconnect switch must be rated for the voltage and amperage of the hot tub circuit. Fourthly, the wiring for a hot tub must be properly sized and installed according to the NEC and local codes. This includes using the correct type and gauge of wire, as well as properly grounding the hot tub and associated equipment. The size of the wire depends on the amperage of the hot tub and the distance from the electrical panel. Consult NEC Table 310.15 for proper wire sizing. Fifthly, bonding is an important safety measure for hot tubs. Bonding involves connecting all metal parts of the hot tub and its equipment together with a solid copper wire. This helps to equalize the electrical potential between the metal parts, reducing the risk of electrical shock. Sixthly, for underground wiring, the wiring must be buried at the proper depth and protected from physical damage. This typically involves using rigid metal conduit, or RMC, or Schedule 80 PVC conduit. The depth of burial depends on the type of wiring and the location of the installation. Refer to NEC Table 300.5 for proper burial depths. Seventhly, all electrical connections must be made in approved enclosures and fittings. This helps to protect the connections from moisture, corrosion, and physical damage. Eighthly, ensure that all electrical equipment used with the hot tub is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, OIL. This indicates that the equipment has been tested and meets safety standards. The amperage requirements for a 120 volt or 240 volt hot tub will vary depending on the specific model and its features. Check the hot tub's nameplate or owner's manual for the exact amperage requirements. This information is crucial for selecting the correct size of circuit breaker and wiring. For example, a small 120 volt hot tub might draw 15 amps, while a larger 240 volt hot tub could draw 50 amps or more. When comparing the operating costs of a 120 volt versus a 240 volt hot tub, several factors should be considered. The most significant factor is the efficiency of the heating element. 240 volt heating elements are generally more efficient than 120 volt heating elements. This means that a 240 volt heater can convert more electricity into heat, resulting in less energy wasted. Another factor to consider is the insulation of the hot tub. A well-insulated hot tub will retain heat better, reducing the amount of energy needed to maintain the desired temperature. The amount of use can also affect operating costs. A hot tub that is used frequently will require more energy to maintain the temperature than a hot tub that is used only occasionally. The ambient temperature can also have an impact. A hot tub located in a colder climate will require more energy to maintain the temperature than a hot tub located in a warmer climate. To estimate the operating cost of a hot tub, use the following formula. Energy consumption in kilowatt-hours or kWh is equal to the power in kilowatts or kW multiplied by the time in hours. Cost is equal to the energy consumption in kWh multiplied by the cost per kWh. To illustrate, let's consider an example. Assume a 120 volt hot tub has a 1.5 kilowatt heater and is used for 2 hours per day. The energy consumption would be 1.5 kW multiplied by 2 hours, which equals 3 kWh per day. If the cost of electricity is 15 cents per kWh, the daily cost would be 3 kWh multiplied by 15 cents, which equals 45 cents per day. Now, let's consider a 240 volt hot tub with a 3 kilowatt heater that is also used for 2 hours per day. The energy consumption would be 3 kW multiplied by 2 hours, which equals 6 kWh per day. However, because the 240 volt heater is more efficient, it may only consume 5 kWh per day to maintain the same temperature. In this case, the daily cost would be 5 kWh multiplied by 15 cents, which equals 75 cents per day. While the 240 volt hot tub consumes more energy per day, it may provide faster heating and better performance overall. The decision of whether to wire a hot tub for 120 volts or 240 volts depends on individual needs and preferences. If faster heating, increased power, and potentially lower operating costs are prioritized, a 240 volt installation may be the better choice. However, if budget is a primary concern and some performance and convenience are sacrificed, a 120 volt installation may be sufficient. Ultimately, it is important to consult with a qualified electrician to determine the best option for any specific situation and to ensure that the installation meets all applicable electrical codes. When installing a hot tub, it's crucial to consider the local electrical codes and regulations in your area. These codes are in place to ensure the safety of people and property and to prevent electrical hazards. Firstly, contact the local building department or electrical inspector to obtain information about the specific electrical codes and regulations in the area. These codes may vary depending on the location and may be more stringent than the NEC requirements. Secondly, obtain the necessary permits before starting any electrical work. Permits are typically required for hot tub installations and ensure that the work is inspected and meets the applicable codes. Thirdly, hire a qualified and licensed electrician to perform the electrical work. A qualified electrician will be familiar with the local codes and regulations and will ensure that the installation is done safely and correctly. Fourthly, ensure that the electrical installation is inspected by the local electrical inspector. The inspector will verify that the installation meets the applicable codes and regulations and will issue a certificate of compliance if it passes inspection. Fifthly, be aware of any restrictions or requirements related to the location of the hot tub. Some areas may have restrictions on the placement of hot tubs, such as setbacks from property lines or requirements for fencing or barriers. Sixthly, follow all manufacturer's instructions for the installation and wiring of the hot tub. The manufacturer's instructions may provide additional information about electrical requirements and safety precautions. It's important to understand the difference between a ground fault circuit interrupter, GFCI, and a circuit breaker. While both devices are designed to protect electrical circuits, they do so in different ways and for different reasons. A circuit breaker is designed to protect against overloads and short circuits. An overload occurs when too much current flows through a circuit, such as when too many appliances are plugged into the same outlet. A short circuit occurs when there is an unintended connection between two conductors, such as when a wire is damaged and comes into contact with a metal surface. When an overload or short circuit occurs, the circuit breaker will trip, cutting off power to the circuit and preventing damage to the wiring and appliances. A GFCI is designed to protect against ground faults. A ground fault occurs when electricity flows through an unintended path, such as through water or a person. This can happen if the insulation on a wire is damaged or if an appliance is not properly grounded. When a ground fault occurs, the GFCI will quickly trip, cutting off power to the circuit and preventing electrical shock. The primary difference between a circuit breaker and a GFCI is that a circuit breaker protects against overloads and short circuits, while a GFCI protects against ground faults. Both devices are important for electrical safety and are often required for hot tub installations. A GFCI is much more sensitive than a standard circuit breaker. It is designed to detect even small amounts of current leakage to ground, which can be a sign of a dangerous condition. Standard circuit breakers are not designed to detect these small current leaks and will not trip unless there is a significant overload or short circuit. GFCI protection is typically required for all outlets and circuits near water, such as in bathrooms, kitchens, and outdoor areas. This is because the risk of electric shock is higher in these areas due to the presence of water. In the context of a hot tub installation, a GFCI is essential for protecting against ground faults, which can occur if water comes into contact with the electrical components. A standard circuit breaker will not provide adequate protection in this situation. When selecting an extension cord for a 120-volt hot tub installation, there are several important factors to consider. Using the wrong type of extension cord can be dangerous and can increase the risk of electrical shock or fire. Firstly, the extension cord must be rated for outdoor use. Outdoor extension cords are designed to withstand exposure to moisture, sunlight, and other environmental factors. Look for an extension cord that is labeled as weatherproof for outdoor use. Secondly, the extension cord must be heavy-duty. Heavy-duty extension cords have thicker wires and are designed to handle higher amperage loads. A hot tub can draw a significant amount of current, so it's important to use an extension cord that is capable of handling the load. Thirdly, the extension cord must be ground fault circuit interrupter protected. This means that the extension cord has a built-in GFCI that will trip if a ground fault is detected. This is an important safety feature that can help prevent electrical shock. Fourthly, the extension cord must be the correct length. Avoid using excessively long extension cords, as this can cause voltage drop and can reduce the performance of the hot tub. Choose an extension cord that is just long enough to reach the outlet without being too long. Fifthly, the extension cord must be in good condition. Inspect the extension cord regularly for any signs of damage, such as cracks, cuts, or frayed wires. If the extension cord is damaged, replace it immediately. In general, it's best to avoid using an extension cord for a permanent hot tub installation. A dedicated circuit with a hard-wired connection is the safest and most reliable option. However, if an extension cord must be used, be sure to choose one that is specifically designed for hot tub use and that meets all applicable safety standards. Remember to consult with a qualified electrician to ensure that the installation is done safely and correctly. When considering the long-term cost savings of a 240 volt versus a 120 volt hot tub, several factors should be taken into account. While the initial cost of installing a 240 volt circuit may be higher, the long-term operating costs may be lower due to the increased efficiency of 240 volt heaters. The amount of energy consumed by a hot tub depends on several factors, including the size of the hot tub, the insulation, the climate, and the frequency of use. A larger hot tub will typically consume more energy than a smaller hot tub. A well-insulated hot tub will retain heat better, reducing the amount of energy needed to maintain the temperature. A hot tub located in a colder climate will require more energy to maintain the temperature than a hot tub located in a warmer climate. A hot tub that is used frequently will require more energy than a hot tub that is used only occasionally. To estimate the long-term cost savings of a 240 volt hot tub, calculate the annual energy consumption of both a 120 volt and a 240 volt hot tub, taking into account the factors mentioned above. Then, multiply the annual energy consumption by the cost of electricity to determine the annual operating cost. Finally, compare the annual operating costs of the two hot tubs to determine the long-term cost savings. Keep in mind that the actual cost savings may vary depending on the specific circumstances. It's also important to consider the non-monetary benefits of a 240 volt hot tub, such as faster heating times and increased power for jets and other features. These benefits may be worth the additional cost for some people. Ultimately, the decision of whether to install a 120 volt or a 240 volt hot tub depends on individual needs and preferences. Weigh the costs and benefits of each option carefully before making a decision. The depth at which underground wiring must be buried depends on several factors, including the voltage of the wiring, the type of wiring, and the location of the installation. The National Electrical Code, or NEC, specifies the minimum burial depths for various types of wiring. For example, direct burial cables such as underground feeder or UF cable must be buried at least 24 inches deep. Rigid metal conduit, or RMC, and intermediate metal conduit, or IMC, must be buried at least 6 inches deep. Scheduled 80 PVC conduit must be buried at least 18 inches deep. Electrical metallic tubing, or IMT, is generally not approved for direct burial and must be encased in concrete. The burial depths mentioned above are minimum requirements. In some cases, it may be necessary to bury the wiring deeper to protect it from physical damage. For example, if the wiring is located in an area where it is likely to be disturbed by digging or other activities, it should be buried deeper. It's also important to consider any local codes or regulations that may require deeper burial depths. Be sure to check with the local building department or electrical inspector to determine the specific requirements in the area. When burying underground wiring, it's important to follow certain precautions to ensure that the wiring is properly protected. Firstly, use the correct type of wiring for underground use. Underground feeder, or OFF, cable is a common choice for underground wiring because it is designed to withstand moisture and other environmental factors. Secondly, protect the wiring from physical damage by encasing it in conduit. Rigid metal conduit, or RMC, and Schedule 80 PVC conduit are commonly used for this purpose. Thirdly, bury the wiring at the proper depth. The depth depends on the type of wiring and the location of the installation. Fourthly, mark the location of the underground wiring with warning tape or other markers. This will help prevent accidental damage to the wiring during future digging or other activities. Fifthly, backfill the trench with soil that is free of rocks and other debris. This will help protect the wiring from damage. Sixthly, compact the soil thoroughly to prevent settling. Settling can damage the wiring and can create a tripping hazard. Finally, be sure to follow all applicable electrical codes and regulations when installing underground wiring. Consult with a qualified electrician to ensure that the installation is done safely and correctly.